In this video, I introduce a reparameterization trick in variational autoencoders. Variational autoencoder is a generative model which consists of encoder and decoder, as shown here, this encoder and this decoder. The variational approximation Q phi is used to approximate the intractable posterior P theta. The variational parameters phi are learned jointly with the generative model parameters theta. The goal is to maximize the log likelihood here. The marginal likelihood is composed of a sum over the marginal likelihood of the individual data point, which can be written as here. The first term is the approximate of the posterior, and the second term is the evidence lower bound on the marginal likelihood of data point I, since the first term is larger than 0. Using base rule and approximating the posterior P theta with the recognition model on Q phi, for example, encoder, the evidence lower band L is written as here. Here we use the chain rule. Finding the optimal parameters theta and phi requires computing the derivative of L with respect to both the variational parameters phi and the generative parameters theta. If an encoder is selected as Q phi, which is applied to extract the statistics of input image, VAE is used to reconstruct the input image since the latent space only contains the information of the input information. The image as shown here, this input image. This is a reconstruction. This encoder is used to minimize the difference between Q phi and P theta. This decoder is used to maximize the log likelihood. Generative VAE uses reparameterization trick to generate samples from Q phi so that the latent variable Z becomes a continuous random variable, which increases the diversity of the generated images. For example, a valid reparameterization is Z calculated by using mu and sigma and SE, where E is an auxiliary noise variable. The evidence lower band is written as here, where Z is computed from mu, sigma, and E, and this is sampled from P. The VAE can be trained through back propagation. As shown here, this generative variational autoencoder, this reference image, and this generation condition on the reference image XI, this encoder, and this decoder. Here we use this Gaussian distribution for the reparameterization trick to generate this Z, which is a continuous random variable. For more details, please check with these references. Thank you. Bye.